Hello. All right. This video is a follow-on to the prior video in which I worked 6 problems that are just random problems that you might see on an algebra final or on a placement test for trying to place out of algebra. I'm doing 7 more problems in this video that go into some other, focusing on some of the linear algebra, just graphing or y equals mx plus b type problems, as well as a few radical problems and simplification of radicals and some exponents. So let's get to it. We got 7 problems. Again, as I wanted you in the last problem set to do, I wanted you to see the problem, try the problem, and then watch me work it. And you're going to get a lot more out of it than if you just sit here and watch me work problems. Again, when you watch someone do something, it seems so much easier, and you learn a lot less than if you try it and then work it on your own. If you get it right, that's great. You did it on your own. If you didn't get it right, you're going to learn more because you're going to see where you made your mistake. Without any further lecturing, I will move on to the 7 problems. Okay, here we go. Here's 3 problems. Okay, so here we talk about, we're going to be talking about slopes and equations of lines, and let's let you get to it and give these problems a go. Okay, number 7, I want you to solve it. Well, no happy cat yet. Try solving this thing on your own. Okay. Pause and solve. Okay, so now what we need to remember is that our slope is equal to y2 minus y1 over x2 minus x1. That's our change in y. Our m is equal to our change in y over our change in x between any 2 points on a line. And it's always the same. It doesn't matter what 2 points you pick on a line. On a straight line, it will always, always, always have the same slope. Okay, so in this equation, you have an x-intercept and a y-intercept. Don't let these words x-intercept and y-intercept fool you. It's just basically saying, what is the slope of a line with 2 points, 2, 0, and 0, 3? So let's find our change in y. And the one key point is that you have to make sure that your point, this is like x1, y1. And this is like your x2, y2. You got to make sure you always keep them in order. So if we use y2, if this is our y2, we have to put our y2 over our x2. And then we're going to subtract our y1 over our x1. Right. So that's going to be 3 over -2, which is equal to -3/2. Okay, there we go. And you can see that they're trying to make sure that it's all about the change in y, right? Because if you did change in x over change in y, you might end up with one of these 2 answers, which are wrong. Or if you didn't know, if you switched up your x2s and your x1s, or you messed up your fraction math, you might get this answer. Okay, so we got our first answer, number 7. Number 8, so we want the equation of a line containing the point 0, -2, and slope 3/4. Why don't you give that one a go? Pause and try. Okay, I'm going to assume that you've come back. Well, this is kind of neat. This is what is this? 0, -2. If we look at that point, 0, -2, what is that? That's our y-intercept. So this is cool, because in our slope is 3/4, and our y-intercept is -2. So we actually know that there's a form of a line which is y equals mx plus b, and this is our y-intercept and this is our slope, so we can just plug these numbers in. So we get y equals 3/4 x minus 2. Boom. We have it. That's our C answer. Good. So we got all these other things running around, but we don't get tricked, because this is a problem that you should just practically be able to go. You can go straight from here straight to here, and then you're on to number 9. Number 9. Okay, what is the slope of the line parallel to the line containing these 2 points? Now, I want you to try this on your own, and then we'll get to the crux of this problem. Try this on your own. Okay. So I'm solving this problem, but let's plot these points first. And let's go 2, 2. This is 2, 2. And 2, -2. Well, what do we got here? We have a horizontal line here. Or sorry, a vertical line. We have a vertical line. And a vertical line, the slope is undefined. We can look at it another way. We can calculate it, and we can say, well, m is the change in y over the change in x. Our change in y here is 2 minus a -2. And our change in x is 2 minus 2. 2 minus 2. So that's 4 over 0. And this is also undefined. So you can either remember that a vertical line has a slope that's undefined, or you can do the calculation that also proves that it's undefined. So given that this line is undefined, all parallel lines to a given line also, all these lines are parallel lines, right? They all have a slope that's undefined. So all parallel lines to the line containing these 2 points must have a slope that's undefined. All right, let's move along to the last, to 2 more problems. Okay, number 10. Try this on your own again, and then come back and watch me solve it. 2x plus y equals 10, and x minus y equals 8. Okay, I'm assuming that you've solved this. You've tried to solve it, and we're just going to confirm that you have the right answer. So let's look at this and say, well, what does it mean? At what points do the lines defined by these equations meet? Well, that's equivalent. This is equivalent to saying, solve this set of simultaneous equations with algebra. These are the same thing. You could graph these lines. You could go about, graphing these 2 lines and then figuring out where they meet on the coordinate plane, Cartesian plane, or you could just solve it using algebra, because we know that algebra and geometry are basically equivalent. So let's solve this equation, and I'm going to do it by elimination. I'm going to use, elimination, because this problem is totally set up to do it. I can just add these down, and I can eliminate my y's, right? So if I add the right side, I get 18, but if I add the left side, these guys, positive y and negative y, will cancel. 2x plus x is 3x, so I get x equals 6. Wow. Well, I actually now know that I actually can know my answer has got to be this, because there's none of these other ones have 6. Well, it could be, yeah, no, it can't be any of these other ones. But let's just go back and make sure that we're going to get a -2 for y, because if we don't, we're in trouble. So I'm going to go back to this first equation and say, well, 2x plus y equals 10. And I know now that x is 6. I'm going to plug that in here. 2 times 6 plus y equals 10. 12 plus y equals 10. Minus 12 minus 12. Y equals -2. Good. So I know that x is 6. Y is -2. That's my answer. I'm sticking to it. Happy cat. Happy cat. Dizzy cat. Let's move on. If you have any questions, if you have any questions, please comment. And I will answer. Either in video or in comments. I mean, it doesn't matter. It doesn't matter to me. Sometimes I have to do a video to explain things, but sometimes just a simple question can be answered in a comment box. All right, let's move on. Number 11. Now we're moving out of linear, kind of the linear algebra mode, and we're moving into this exponents and terms, multiplication of monomials, and let's just see what we get here. Try this on your own. Try this yourself. 3x y squared z times -4 x y cubed z to the 4th. All right. Well, first of all, I know that the way I multiply these things is I multiply my coefficients. Multiply your coefficients, and you multiply each factor with the same base together. Because really, this is all just a big thing multiplied together. This is just 3 times x times y squared times z times -4 times x times y cubed times z to the 4th. And I can, because everything's multiplied, I can just rearrange at will. And so I'm going to rearrange it like this. I'm going to put my x's together. I'm going to put my y terms together. And I'm going to put my z terms together like this. Because this is, it's commutative. Multiplication is commutative. Okay, so I can immediately eliminate, these guys because they're positive. I know my answer's got to be -12. Well, I know that's not right. So now I'm down to B or E. But let's see, x times x is x squared. There's 2 x's. Y squared times y cubed is y to the 5th. And if you need to, work that out, it's, well, y squared is y times y. Y cubed is y times y times y. And this whole thing is y to the 5th. It's not y to the 6th. It's y to the 5th. Similarly, z is z to the 5th. So we got x squared. So it's not this one. It's this one. It's E. Good. Happy cat. Happy cat. Moving on. Last two. So now we have simplification of radicals. So this is still exponents kind of, but we're looking at it in a different light. We're simplifying our radical expressions. And one of the easiest ways to go about, well, let's let you solve this on your own, and then I'm going to work with you. So pause and solve. Pause plus solve. Okay, I'm going to assume that you paused and solved. Now, one of the best things you can do with radicals is you can just break them up. radicals, if I, the rule says the square root of a times b is the square root of a times the square root of b. So I can just break up a radical with multiplications, and it makes things way easier. So I'm going to change this into the square root of 4 times the square root of x times this to the squared times the square root of y to the 4th, which is easy because I know the square root of 4, that's 2. The square root of x squared is x, because it asks what times what is x squared, x. And the square root of y to the 4th is y squared, because y squared times y squared is y to the 4th. Bam. A is my answer. And the way you can check it, if you really, really want to, is you can just say, well, 2xy squared times 2xy squared equals 4x squared y to the 4th. And that's what's inside here, right? That's what the definition of square root means. It means what times what is going to give me the thing inside it. We followed our rules of simplification. Bam. Now let's move on to number 13. The first thing to know, I'm going to give you a hint, right? Y to the negative 2 is equal to 1 over y squared. And once you know that, you should be able to solve this guy using the rules that we've learned this year in algebra. Okay, so pause. Here you go. Pause and solve, and then we're going to come back to it. Oh, here, put our happy cat over here. All right, let's go. So we're trying to find the square root of x squared y to the negative 2. Well, knowing what we know right here, this is equal to the square root of x squared times 1 over y squared, which is equal to the square root of x squared over y squared. Well, there's another rule that the square root of xy is equal to the square root of x over the square root of y. Similar to this rule here. All right, the multiplication rule, two things multiplied together is equal to the square root of those two things. Similarly, the square root of the product of a square root, the product of two things divided is the product of the first thing, the square root of the first thing divided by the square root of the second thing. So we can rewrite this guy as the square root of x squared over the square root of y squared. Well, the square root of x squared is x, and the square root of y squared is y. Bam. Square root of x over y. Boom. A. 2 A's in a row. All right. Happy cat. Now, again, if you have, oh, look at this. Let's put go back. Happy cat. Kind of an invisible happy cat. Ooh, happy cat right over our answer. And we can put another happy cat right over our other answer. Ooh, wow. It's pretty cool. This is called Sketch.io. Right here, sketch.io.sketchpad. It's a really cool program. You can use it too. And you can draw with it. You don't have to do math with it if you don't want to. All right, well, enough for today. Hopefully this was a very, hopefully this was a useful exercise. You're welcome. I might do another sequel to this. There are more problems, more test problems I can throw out there. It's kind of neat to do problems that are different, like back to back to back, because it makes sure your brain's engaged with the entire unit of algebra. It doesn't lock you into certain ways of thinking. If you did a square root problem 10 times in a row, you're going to get locked into this square root thinking. But if you do a square root problem and then a linear algebra problem, y equals mx plus b problem, and then you get a solve for x problem, all mixed together, it kind of keeps your brain on guard. And that's what you're going to need to do on some of these challenge tests and these algebra finals. So I will leave you with that. Good to see you again. Hopefully this was useful. We'll talk to you later.